Alright, so our next video is over section 4.4, which is about finding slope and rate of change. The first thing I would like to point out is that the word slope should be tied to motion in your head. How does our line move? How does it change? The formal definition is for a non-vertical line, it is the ratio of the vertical change, the rise, to the horizontal change, the run, between any 2 points on the line. We always represent slope with the letter M. It's because the man who put together, or the man who's credited with the coordinate plane, his name was Descartes. We call him, he was French, and he referred to slope as he used marcher, and for those who take French, you know that means to walk, and that's why we use the letter M. Now, the rate of change, we're talking about slope still, but we're comparing change in one quantity to change in another quantity. And we'll really know that we're talking about a rate of change because we'll have specific units. But rate of change and slope are interchangeable. Now, we have 4 types of slope that we'll be looking at. We'll be looking at positive slope, negative slope, zero slope, and undefined slope. And this is talking about just looking at the picture as a whole, which way is your line going? And if you look from left to right on your graph, and you see that your line is going uphill, you can say that you have positive slope. If when you look from left to right, we look as though we're having negative slope or going downhill. Zero slope is what happens when we have a horizontal line. And undefined slope happens when we have a vertical line. Now, there's a little bit of a hint to help you remember zero slope and undefined slope. Remember, I gave you Hay Vex to help you remember the equations. Hay, so y equal to a line. But if you want to know about slope, remember that when we look at a z, the top of the z and the bottom of the z are parallel to the horizon. So we know that zero slope goes with horizontal lines. And the other trick to help you remember is that we could write a U this way with a line on the end of it to remember that undefined slope goes with vertical lines. So the first thing I'm going to ask you about is classify the slope, or look at the line and tell me what type of slope you have. Those problems are nice and easy. And the second type of problem are finding slope. There are problems where you'll be given just 2 points, and there are problems where you'll be given a graph. Let's talk about the graph first. So what if we were given those 2 points, -2, 0, it's this one right here, and the point 4, 3, this one right here. How would I find the slope between those 2 lines? Well, the first thing that I always do is draw in the triangle or the arrows to connect those 2 points. Always work your graph from the left side of the line to the right side of the line. You'll notice that I drew in my vertical line. And now if I put in that horizontal line to connect my 2 dots, or my 2 points, you can see that we're talking about how is the vertical change related to the horizontal change. So when I look at these problems, I always read my graph from left to right. Always read from left to right. And we always put, when we go to find slope, remember we use M, we always put how much did I fall or rise over how many units did I move to the right. When you count these, make sure that you're counting blocks and not lines, so that my rise, it's positive. When I rise, I have a positive number. My rise is 1, 2, 3 blocks. So I had a rise of 3, and I moved to the right 1, 2 blocks, 3, 4, 5, 6 blocks. I moved to the right 6 units or 6 blocks. We have to reduce every fraction, so 3 over 6 becomes 1/2. And we know that the slope of the line is 1/2. If we come over here and we start trying to use the formula, we're going to find that we do very similar ideas, except we don't have a graph. The first is that you could go ahead and memorize this formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. It just says that you have to pick a point to call the first point and pick a point to call the second point, and you should subtract the y values. That'll find the vertical change. Over subtract the x values, that will find the horizontal change. But you don't even have to memorize this formula. If you just get in the habit of taking your 2 points and stacking them on top of one another. So if we say x sub 2 comma y sub 2, and again, it doesn't matter which point goes on top. So I'm taking that first ordered pair, I'm stacking it on top of the first ordered pair. I think I said that right. Now that they're stacked, we're going to sketch in our slide. Remember, it's really a slide. So we've stacked our points, we've slid our points, and now we're going to subtract on the top of the slide oops, I didn't label this properly. This point down here, remember those were our sub 1s. So make sure that you have sub 1s even though I didn't. So y sub 2 minus y sub 1. So the top of the slide says y sub 2 minus y sub 1. And the bottom of the slide says x sub 2 minus x sub 1. X sub 2 minus x sub 1. And that is still equal to slope, m. So same formula, but so that we don't have to memorize it, we could use stack, slide, subtract. Stack, slide, subtract. I think there are a couple other practice problems. Yep. So let's do one together, and then I'll give you some time to practice it on your own. So we take our 2 points and we stack them. It never matters which one goes on top. So I'll stack negative 7, 8 on top and the point 3, 3 on the bottom. Or if you so choose, you don't like this method and you want to use that formula, you go for it. Y minus y gives me 8 minus 3, and x minus x gives me negative 7 minus 3. 8 minus 3 is 5. Negative 7 minus 3 is negative 10. When I simplify that fraction, it becomes negative 1/2, and that is my m value, or slope. For every 1 point I go down, I'm going to move 2 points to the right. Try B, C, and D with this formula.